the cable in one because I think that should be sufficient to hold it in place. Okie dokie. And it's coming away from the connector. So it's coming here, then goes down there. So the cable from our panel, we understand, is this one. Yes, it is.
Так, вот он лежит, получается, на середине фиксирующей платы.
So right now it's coming across the middle of the
Подтверждаем, но сейчас откроешь, еще посмотришь маркировку.
Restraint plate. Can you confirm that that's the right cable? Yes, but when you open it up and check the labeling, that will be a double sure. Okay.
Так, маркировка разъема SPRG 1X1.
It's SPRG X1.
Все принято.
SPRG 1 dash X1 is the labeling. Copy Piotr, and that's the right one.
Подтвердили.
Copy, you confirmed.
Так, готов приступить к распаковке разъема.
Ready to demate the connector. Please.
An excellent view of Oleg Novitsky on the left, Pyotr Dubrov on the right, working at the Zarya module in the replacement of a fluid flow regulator unit. Zarya having been launched more than 22 years ago
In opening.
on a Proton rocket from the Baikonur Cosmodrome in Kazakhstan, the first component, the first element of the International Space Station to be launched in the era of the ISS.
На плате разъем, разъем панели.
Leave the connector on the plate.
Сверху в лирку там на панель и клапан закрываешь.
Then close the valve. And demated cable needs to go into a cable clip. Here's the clip.
Тугая.
Is it tight?
Я не две, в одну закрепил, потому что...
Хорошо, хорошо, конечно.
I just put the cable in one because I think that should be sufficient to hold it in place. Okie dokie.
Station, this is Houston. Are you ready for the event?
Houston, I am ready for the event.
People Magazine, this is Mission Control Houston. Please call station for a voice check.
Station, this is Tom Knepp with People Magazine. How do you hear me?
Hello, Tom. I hear you loud and clear.
Hi, Megan. Good to talk with you again.
Yes, good to talk with you again, Tom.
This is a first for me. So, but thank you for doing this. Where are you now exactly in the ISS?
So right now, I am in the Columbus module, which is the European Space Agency's laboratory module as part of the U.S. operating system on the International Space Station.
And what country are you over?
Well, when I just checked our map, we are over Australia right now. We spend a lot of time over the ocean, of course, but right now we're over Australia, and it's dark there right now.
So it's nighttime. It gives me a good sense of where you are. I know you've been up there about a month. How's it going?
Well, it's going really great, actually. It's an amazing thing to get to spend this much time in space and really get used to it, start to adapt to the environment and get efficient moving around and living and working in space. It's really been incredible.
I bet. It's a once-in-a-lifetime experience, obviously. I know, that the ISS has been on the news this morning with regard to the space debris that put a hole through the robotic arm. Can you talk about that a little?
So we learned recently that there was a strike on the robotic arm that actually turns out occurred back in February of this year, and just a recent survey brought that to light with some photographs. And the team on the ground has worked very hard to absolve that, to really look in detail at what that actually is. And you probably have more detail in the news right now, but what we understand is that the arm is operating completely normally. It has done some significant tasks since it received that hit, and is expected to be completely operational for all of the big tasks that we have coming up.
And I understand you had to dodge a piece of space debris on your way in the Crew Dragon to the space station. Is that true?
So we were alerted that there was some debris near our vehicle, and it was a kind of what we would call a late notification, meaning that our team found out about it late. So we immediately got into our spacesuits and zipped up so that we would be safe. And then it turned out that it was in fact not, there was not any debris, that it was a false alarm. But we proved that we could get into our spacesuits really quick.
So you didn't have to make any maneuvers in order to avoid it.
That's correct. Yeah, we just continued on our regular path.
Well, tell me a little bit about the past month. What's the coolest thing you've seen since you've been up there?
Well, Tom, one of the things that I love to do when I have the time is to look out the window. We have several different windows on the International Space Station, and we spend a lot of time over the ocean, and so sometimes you can see these very large thunderstorms out over the ocean. And I saw something recently that I've never seen before, which I think is sort of lightning related, but it was actually lightning that came up away from the surface of the Earth. It may have been what scientists call a blue jet, and I don't know a lot about the phenomenon, but I came back in and saw some of my crewmates, and I said, "You'll never guess what I just saw." And I described it to them, and they said they thought it was one of these blue jets that's a lightning-related phenomenon that's very rare. So it was pretty cool to see it.
Wow, that is very cool. What would you say is the highlight of your mission so far?
Well, certainly launch and docking was a big highlight for us. And then once on the International Space Station, I would say that from a science perspective, getting to operate with the Celestial Immunity Project, which is a study that looks at immune function and could contribute to developing vaccines back on Earth, that was a real highlight for me, getting to participate. I'm not a biologist by training, and so I had, a camera over my shoulder with an expert talking me through it every step of the way. And that was very exciting to be so hands-on involved in an important research project like that. We have a launch of a SpaceX cargo vehicle coming up this weekend, bringing 7,000 pounds more science to us. So we're excited to get that here, get it unpacked, and get started with all of that. That will include a couple of spacewalks, and so we are preparing for that as well. And I know those are going to be a real highlight too.
Wow. Are you expecting any treats from Bob and Theo? Are they sending anything up to you?
I think we can expect a care package, and I know the team back home will focus on sending us some fresh food as well, maybe some citrus, but I expect there'll be some special care package in there from Bob and Theo as well.
Yeah. I know you have a packet of food there with you right now?
I do have some food I can show you. We have a pretty varied, different kinds of food up here. That some of it's dehydrated that we have to rehydrate. Some of it has been heated to preserve it, so we just have to reheat it. I'll show you what that different packaging looks like. This is the food that is already hydrated, so we just have to heat it. So it looks similar to the kinds of meals that our soldiers get in the field. This is actually brown rice in this packet right here. Then I have some dehydrated food in this packet. This outer packet is actually a protective packet to help the food stay shelf stable for a little bit longer. So you actually have to open this outer packet to get at the food inside. So I'll take a quick second to do that.
Sure.
This is a cashew chicken curry. It's what I'm going to have for my dinner tonight. So you can see that it's dehydrated, and I have to add water in through this opening here, and then I'll put it in the warming oven for about a half an hour so it gets really nice and rehydrated and warm. So that's pretty nice. We also, of course, have a variety of different drinks. The Food Lab packed me my favorite tea that I turn into iced tea. We do have a teeny tiny refrigerator on board that we can cool off some drinks or small food packets. So they really do take care to try to give us lots of different variety in flavors and textures and temperature as well.
But it has to be pretty, it can't be, you can't have any crumbs when you're eating, is that right?
Well, we do try to minimize crumbs. We don't have a lot of bread up here, but we do have some crackers and cookies that will make crumbs. And then, of course, the liquid food, if you move too fast, you can spray little droplets of liquid everywhere. So you try to be really careful, and you don't wear your nice shirt to dinner.
Now, what did you have for breakfast this morning?
This morning I had, I had grits with butter and some sausage.
Well, that sounds pretty good. Tell me, what is it like viewing the stars from up there? I imagine it's just incredible. With no light pollution, the stars must look just phenomenal.
You know what? They do look phenomenal. Very similar, of course. The patterns are the same. We're still just as far away almost as you are when you're on Earth. But because you don't have the atmosphere between you and the stars, there isn't that twinkling that stars will do, and you can really see what color they are. But I'll tell you, a lot of the time when we're looking out at nighttime, we're looking at Earth, we're looking at the city lights, and we're looking at home.
I guess that's a little more interesting to you, huh?
Yeah, it's nice to think about, the different cities around the world and what people might be doing and just think about, hey, what places might I want to visit now that I've seen them going overhead?
Yeah. And how often do you get to chat with Bob and Theo?
I try to speak to them every day, even if it's just for a couple of minutes to say hello. And then once a week we have a nice video chat where I get to visit with them and we can see one another for about 20 minutes or so, which is really nice.
And is Theo doing okay? Is he handling you're being in space okay?
He's doing great. He and his dad are having a ton of fun. He's glad that school is out, and he's loving spending time at the swimming pool. So, yeah, he's doing really well.
Oh, good. Good. That's good to hear. How does it feel to look at Earth from space?
Well, I'll tell you what, Tom, we have such a beautiful planet. Really, the most overwhelming feeling is one of wonder. Even when you're going over the ocean and you just see clouds, all of the different varied patterns of clouds are just beautiful. And you end up feeling very protective towards the Earth because you see every time we get a sunrise or a sunset, you see that lens of the atmosphere, illuminated, and you see how thin it is relative to the size of the Earth and relative to the vast blackness of space. And so you sort of feel very protective, very proprietary about this special planet that we have.
I'm sure. It gives you a whole new perspective, I'm sure. Literally. What do you spend most of your time on?
Well, one of the really cool things about this job is that every day is different, and so we spend time on different things really every day. But kind of two big categories. We spend time doing maintenance, so keeping the space station running and keeping all the science facilities running, and then we spend time doing the actual science. And so those are kind of the two big categories. But like I said, every day is different, so that's what makes it very interesting. We also do have to spend time moving things around because we do keep a lot of equipment on board the space station. So, for example, because we're getting ready to do some spacewalks, we had to clear a lot of equipment out of our airlocks, which is where the spacewalking crew members will exit and re-enter the space station. And so you can see I have a spare spacesuit that we're not going to use in the upcoming walks is been parked here in the Columbus laboratory to get it out of the way. So we do spend some of our time every day moving things around and looking for the things that we need.
And what about microgravity? Have you gotten used to that yet?
Well, I'll tell you what, it's pretty great. It's a ton of fun. It's a wonderful way to move around. I feel like I get a little bit better and a little bit more efficient every day. And I, am trying off different maneuvers as I take a corner at high speed or changing speed. You want to obviously be careful not to run into anyone else or run into any of the stuff that we have. And we do have a lot of stuff, but it's fun. It's fun every day. It's fun all the time. Working in microgravity. One of the challenges, though, of course, is it makes some things very simple. You can move things like a spacesuit that's hundreds of pounds. I can move it very easily, but it also makes other things very difficult. So you have to figure out how to place your body so that if you do need to move a mass and use a lot of force, that you can still do that. So it's got its pluses and minuses for sure.
And what about sleeping in microgravity? I know you sort of have a locker you get into, right, where you have you sort of sleep inside like the size of a phone booth. Is that correct?
That's exactly right. It's about the size of a phone booth for those people who remember what a phone booth is. And it's very quiet. It has some acoustic paneling, and you have your own, you have your laptop in there, and your sleeping bag is tacked to the wall. So sleeping, again, pluses and minuses. It's very comfortable in the sense that you're floating. You don't have any weird hot spots as you might laying down on Earth. But also your brain is wired from your whole life living on Earth to feel that sensation of lying down. It's what relaxes you and helps you go to sleep. So I do find it harder to fall asleep because my brain is not quite programmed yet to fall asleep in microgravity. So it does take me a little bit of extra time.
That's fascinating to hear. I did want to, going back to food for 1 second. I know I've read that your taste buds are a bit muted up there in space. Is that correct? So so astronauts enjoy spicier foods for that reason?
I have heard that people's tastes will change in space. I don't know that my tastes have changed very much, but the food that we get is very healthy. It's and by that I mean it's very lean and low sodium. So one of our solutions to that is to add hot sauce, which is one of the condiments that we have. We do also get salt and pepper. We get a whole variety of condiments: ketchup, mustard, garlic, all kinds of things. But one thing that's kind of interesting about the salt and pepper is that it has to come in liquid form because otherwise it would make a huge mess. So I can show you what that looks like. This is actually a bottle of liquid pepper. So it's been pepper that's been dissolved in water, and so you can squirt this into your food packet instead of trying to shake pepper flakes on your food, which would be a big mess.
Kind of pointless.
Yeah.
Thank you for that demonstration. How do you decompress after a long day?
Well, if everybody is done around the same time, then we'll often gather around the dinner table in the galley, and we might just eat dinner together and tell stories just like you would back on Earth. I'll also, if I'm on my own, I'll hole up in my crew quarters and I'll read a book. Of course, it's nice to look out the window, but if it's daytime outside and I'm trying to wind down to get ready for bed, then I don't want to be looking outside at the bright sun. But there's a lot of other options. We have movies, we have music, we can make phone calls, so there's a lot of ways to wind down. Just like at home.
Well, you've gone through 1 month. You have 5 months left up there. Is that right?
That's right. It's 1 month down and 5 months to go, but we got a lot of work ahead of us, so we're looking forward to it.
And what in particular will you be focusing on for the rest of your journey?
Well, like I said, really every day, every month is going to be different. I think this next month is going to be extraordinarily busy for us when we get the new cargo vehicle. Lots of new science projects that we're going to be working on, as well as the spacewalks, which involve some robotics. And so really that's the horizon that I'm looking at, is that 1 month ahead of us and everything that we're going to get done in that amount of time. And I think every month is going to have some big event that's happening for us to focus on, which is a great way to get through a long period of time like that.
Right, and you have to exercise about 2 hours a day. Is that right?
That's right. We get exercise every day, which is great. We have a treadmill, and we also have a stationary bike, and then we have a resistive exercise machine that helps keeps our muscles and bones loaded, so we don't lose muscle mass or bone mass up here as well.
Yes, yeah, that's fascinating to hear, how that can happen up there in space. I guess it's obviously the importance of that is for missions to Mars and longer space missions. We have to know how to take care of the human body on those long trips coming up.
That's right. One of the big things that we do up here, a big area of research, is what we would call countermeasures. So for the effects of micro-G on the human body. So if you're going to go as far as Mars and the trip is going to take a while to get there, and you're not going to have an Earth G or even a Mars G the entire time, you need to know how to keep the human body healthy so that when you get out of your spaceship, you can still walk around and do the research on Mars. So that's a big part of what we do up here as well.
Very cool. Well, thank you so much for chatting with me today, Megan. And is there anything else you'd like to add before I let you go?
Just thanks for joining us. Thanks for your interest in what's going on in the International Space Station. We're busy up here every day, so I encourage folks to look us up, get outside and wave as we go overhead.
Yeah, they can. I actually have the. You can log on to Spot the Station, I think, .org or .com, and get alerts to when the station is passing overhead, which I've gotten a few of them over the last few weeks, but looking for you up there. But it's been cloudy on the couple of times I've gotten them, so I'm looking forward to when I can actually spot you up there.
All right, Tom, I hope you keep trying. Don't forget to wave.
I will. I sure will, Megan. Thank you so much.
Station, this is Houston ACR. That concludes the event. Thank you.
Station, this is Houston. Are you ready for the event?
Houston, we are ready for the event.
European Space Agency, this is Mission Control, Houston. Please call station for a voice check.
Station, this is David Honess with ESA. How do you hear me?
Hey David, this is Station. We hear you loud and clear.
Hello, Thomas. Good afternoon. You are now connected with ESRO France, Estonia, and Austria. I will hand over to you for some opening remarks, and then we'll open the floor to questions.
Yeah, I'm glad to be here with you guys today. It's always a pleasure to welcome students and teachers and educational efforts on board the space station. As you can see, in the Columbus European Laboratory, and I'm ready for your questions.
Okay, thank you. So we will begin with our first two questions from ESRO France. France, please go ahead.
Angélique Caudel from ESRO France. I have a question from Bartholdi High School in Colmar, and the student of Mr. Patalano, which is a biology teacher. The question is, could you please talk about research done in space by ESA involving plants and recycling?
Yeah, it's a great question. As you know, we don't have a closed loop system here. We need to be supplied from the Earth once in a while with water and oxygen and things that are necessary for us to live. But we're trying to close the loop as much as possible. There's a few experiments run by ESA. There's one on the ground that's called MELISA, which is a long acronym that pretty much means that we're trying to close the loop and have food, water, and O2 production in a closed loop system, self-sustainable. On board the space station, there's been one experiment that was called Artemis Arthrospira, and basically what we did was we took an algae that's called spirulina, brought it up to the space station, and tried to see how it could absorb CO2 and produce O2. So that would help us tremendously, and maybe hopefully in future life support systems will rely more and more on plants to produce our oxygen and scrub the atmosphere from more carbon dioxide.
Thank you. Very interesting, Thomas. Now I have a question from Joliot-Curie Primary School in Saclay, near Paris, and the pupil of Mr. Tesser. The question is constructing a moon based by 3D printing buildings using moon rock dust, the regolith, still considered a possibility instead of bringing materials from Earth?
Yeah, absolutely. It's very much a possibility. As you can imagine, it doesn't come in cheap to send all the material we need on the moon to construct a lunar base and do our exploration program on the surface of the moon, which we'll do in a few years. So using in situ materials are a very promising way to approach those problems. One of them is regolith. Like you say, it's a fine, powdery, loose, kind of dusty material, gray, that's omnipresent everywhere on the surface of the moon, and it can actually be compressed. It can be heated. You can pretty much build bricks made out of regolith, and you could build pretty much anything you wanted out of those bricks. It can also be turned into a cement-like mixture, which can be extruded from a 3D printer, and you could build more complex shapes. And that's gonna be what we need to build a habitat, to build modules, and to build our equipment on the surface of the moon. So yeah, it's very much a possibility, and it's being studied by ESA as we speak.
Thank you, Thomas. Now we will switch to Estonia. Estonia, please go ahead with your first two questions.
Thank you. Hello, Thomas. My name is Ingrid Rõigas, and I am a physics teacher at Viimsi High School. My first question is, how was the preparation for the Alpha mission different to the preparation for your previous mission Proxima in 2016? What new skills did you have to acquire?
It's a great question, and I think some of the things were the same. The station hasn't changed a lot. It has changed, but not too much. So some of the stuff I didn't have to redo. The spacewalk training was the same. Things like this. Some things were different as far as really technical differences. I had to train on the Crew Dragon, which was my means of accessing the station this time, not the Russian Soyuz like last time. So it was a lot of technical lessons, a lot of time in the simulator, getting used to the suits and getting used to the rescue scenarios and all the failure that could possibly happen. So that took me a lot of time. Obviously getting familiarized with our science program, which is different this time. Every single mission has new scientific experiments that you need to be trained for. I think overall the big difference might have been psychological this time. Maybe I didn't try to absorb all the knowledge. I knew that some things I was not going to be needing because I can rely on the teams on the ground to provide that information if I need it. So I kind of focused more, I organized myself a little bit more, and maybe I was more efficient, but I think it happens all the time when you do something for the second time. It's not specific to space. You tend to be more efficient the second time. to get into a frightening experience of any kind on orbit. So we've had a few false fire alarms in the middle of the night. So you wake up in the middle of the night, the big red light is going off, and the sirens are going off, and the warnings are going off. So it doesn't happen very often, but it happened to us. I mean, thankfully it was a false alarm. We didn't have really anything major. We had a couple, situations during EVA when you had to pay a little bit more attention, but thankfully, I think the most frightening situations were in training, and it's not even really frightening, but you put yourself in those situations where you have to react, where you have to adapt. We've done some caving training on the ground with ESA. We've done some survival training. We've got some underwater training. So this is I wouldn't call it frightening, but I would call it, certainly it asks you, it requests that you, demands that you adjust your focus, that you're sharp, and that's why we do those trainings, so that when the time comes on orbit, when you have to use those skills, you're ready.
Okay, and now we will switch back to Austria. Austria, please go ahead with your first two questions.
Hi, my name is Joachim Eichinger. I teach mechanical engineering at the HTL Wels, and my first question is, does looking down on Earth from the ISS change your attitude towards sustainability? And looking at our planet, what did going to space change about your perceptions about Earth?
Yeah, it's a great question. I think looking at the planet from the space station, all the astronauts have the same reaction. It's very human. When you're on the planet, you know that you have to take care of it. You know that it's not infinite. You know that the resources are finite. The energy that we have is not unlimited. But it's just a knowledge that you have with your brain. When you take a step back and you put yourself in low Earth orbit and you look at the planet, you can actually see it with your own eyes, with your own perception. It puts those global problems at your individual scale. And then you feel that something needs to be done. So really, what it sounds like it's obvious, but what strikes lots of astronauts is how fragile the planet is, how it's small, how it's tiny, how it's finite, and how there's really nothing around it. I mean, it's the deep blackness of space. There's no life as far as we know. So really taking that step back, I think, changes your perception. It doesn't change the facts. We know the facts, but it changes your perception, and then it makes you want to do more for the environment when you come back.
Hello. My name is Josef Eder. I am a physics teacher in Borgstrasse Walchen, and this is our first question. What happens if something breaks? Could astronauts repair most things on their own, for example, by using 3D printing?
It's a great question, and things break once in a while. I mean, it's like everything. Those are very complex systems, as you can see around me. So there's a lot of engineering, a lot of effort are being put into the systems on the ground. But obviously, it happens once in a while that they break. We do really two types of maintenance. We do preventive maintenance. We try to prevent anything from breaking. So we replace some spare parts before they hit their service life. We maintain, we clean, we inspect a lot of equipment. That takes us some time during our work days, during our weeks on the ISS. We also do corrective maintenance with the help, again, of the experts on the ground. They know the systems much better than we do. They know the equipments much better than we do, and they guide us to do what needs to be done to repair the systems when they break. Actually, it just so happened this week that we're trying to fix our second new toilet that for some reason refuses to work, and we've been spending a lot of time, and the ground teams have been spending a lot of time trying to MacGyver our new toilet. So it happens regularly. As far as 3D printing, we just last week printed a spare part from the 3D printer that's right next to me here on Columbus, and we installed it on our Brion processor assembly. The old part is not really of the dimension needed, so we printed a new one and we've installed it. So it happens once in a while that we use 3D printing to cover our needs as far as maintenance.
Wow. Cool. Okay, so we will now switch back to France for one question. France, please go ahead.
Oui, bonjour Thomas. I am Lionel Claire, physics teacher at René-Cassin College, a secondary school in Vielmier-sur-Agout. Our question is, how is water recycled on board the ISS?
Yeah, it's a great question. We try, obviously, we can't rely on being resupplied in water all the time. So we recycle a very high percentage of our water. All the perspiration is collected and urine is treated. We have actually 2 racks. Racks are those big elements that you see around me. One is treating urine, and it's pretty much being cleaned, being centrifuged. We try to remove, being filtered, try to remove all the impurities. And then that water is being fed into our water processing rack, which is also treating our perspiration water that's collected all over our station. And really what it does is it filters the water a lot, try to remove all the impurities once again, and then it boils it to really high temperature, and then it condenses it back into its liquid form. After that, it passes through a series of sensors to determine whether or not it's good for us to drink. And the current requirements on space station, it's actually 100 times higher. Water has to be 100 times cleaner than what you get from the tap in most cities or town, at least in the US, but I think in Europe it's pretty much same standards. So we drink very, very clean water, and with our installations that we have on orbit, we managed to recycle 90% of our water, so we have minimal resupply from the ground. And again, all that technology can also be applied to the same system, same problem on Earth, and try to improve life sometimes in the areas where you need cleaner water.
Thank you, Thomas. Okay, so we'll now switch back to ESRO Estonia for one question. Estonia, please go ahead.
Thank you. Hello, Thomas. Here is Ingrid Regas again. My second question is, your last mission on the ISS was Proxima in 2016. What are the most significant changes in the ISS compared to 5 years ago?
It's a great question. There's so one of the changes that I've already mentioned is that now there's 2 ways of access, 2 means of access to the ISS. The Soyuz is still doing great. That's what I call the kind of the East Road, and then there's the West Road launching from Florida, Cape Canaveral, and for now it's the Crew Dragon from SpaceX. So that's pretty much a big change. Not for the 6 months that you spend on orbit, but for the ride up and down. There's been a lot of changes inside the ISS. Some systems have been improved. Some science payloads have been flown up. Like I said before, the science changes all the time. But there hasn't been a new module. In fact, the newest module, this Russian module, is called NMLM. It should arrive soon in July. So we're very excited to add a new room to our house, to our space house. On the outside of the ISS, one of the big changes that's actually ongoing is we're trying to upgrade the solar arrays, and we might have to go outside the door and do a couple spacewalks to install new solar arrays to augment the power system on board the ISS. As far as ESA, we now have a new exposed platform just right there outside of Columbus. On the other side of that wall, you can't see it, but there's a platform that's called Bartolomeo, and it enables the European science community in general to have access to also the outside of the space station. So now you can do research inside, but you can also have payloads on the outside. So the space station is an ongoing, it's a constantly changing work environment, and it's going to keep being like that until it's decommissioned, and hopefully in a very long time.
Okay, and now we'll go back to Austria for one question. Austria, please go ahead.
Hi, it's Joachim again. Can you talk about future plans of alternative ways to travel and live in space?
Yeah, future plans for traveling in space. I think they're happening as we speak. Like I often said that it's now is the golden age of space travel. We have a lot of different vehicles flying. We have a lot of different ways to get to space. It's never been the case. I mean, there's so many now opportunities to go to space, and so many different companies and agencies and countries being involved in space exploration. I think what you see on one hand is try to open space travel to a more diverse population, not only professional astronauts, but also some other types of careers and backgrounds. background, and this is happening. This is not necessarily bad. I mean, we don't have anything against it. If anything that can give momentum to space exploration, I think is good. And also what's happening is we're trying to do space exploration in a more sustainable way. And we have projects in Europe to build some recoverable first stage vehicle. We will do some first stage landing with Prometheus. It's a very important project for the agency as far as launchers are concerned. Access to space, which is still kind of the big bottleneck to get to space. Also, I think a new way, I don't know if you can call it new way of travel, but maybe new destination is going to be further and deeper into space. We've been exploring, we've been doing science in low Earth orbit for a long time now. Now it's time to take a step a little bit further and go forward to the moon with a more permanent presence. And this is what the Artemis program is trying to achieve, and this is what all the agencies are committed to. And so hopefully in the next few years we'll see manned mission, human mission going to the moon, and hopefully then in the years after to the surface, building a more permanent presence, and then on to Mars. So that's our dream, that's the path, that's the goal, and I'm excited to see it happen in the next few years.
Thank you very much, Thomas. I've just heard that we have time for one more question from ESRO France. France, please go ahead.
Hi, Thomas. Nice to meet you. I am Sandrine Guerard. I am a biology teacher in Alexis Monteil High School in Rodez. The question of my student, and particularly Clément, is what happens to waste in the ISS, and what can and cannot be recycled in ISS, and finally, where does the organic waste from the ISS go? Thank you.
Sorry, I didn't really hear the question. I'm sorry.
I'll just repeat it for you, Thomas. What happens to waste on the ISS? What can and cannot be recycled? And where does the organic waste go?
Oh, right. Thanks. Yeah, sorry for that. We try to recycle as much as we can on the ISS, but obviously human solid waste cannot really be recycled. And there's also a lot of other types of waste, like food waste, that we've been fortunately producing. We're trying to limit it in the first place, trying to create as little waste as possible. And whatever we cannot treat, whatever we cannot proceed, then we pack it in a cargo vehicle. Those cargo vehicles bring up all the supplies that we need, and then on the way down we pack them with our trash pretty much, and then once they leave the ISS and they're deorbited, they re-enter the atmosphere in a destructive re-entry, so they're being burnt up, they vaporize, and they get us rid of all our trash. So that's the concept that we have right now. So next time you see a shooting star, well, think it could maybe be astronaut trash leaving the ISS.
Okay, thanks very much, Thomas. I'll give you a quick chance to say goodbye to the three sites, France, Estonia, and Austria.
Yeah, absolutely. And thanks again. All the great questions, very much on point. So it was a pleasure to have you guys on board the ISS today. Thanks to everyone who was involved in the preparation of this event. Like I said, it's always exciting to share the adventure because we're isolated, we're confined to the ISS, but those events give us, also for us, a chance to open up and try to reach out to the people. I know there's a national selection ongoing. I don't know if you guys are thinking about it or if you're talking about it, but I think it's an exciting opportunity. I hope we'll see many applicants, and I'm excited to follow this adventure too for the new generation. So thanks for everyone for joining today, and maybe see you in a few years on board the ISS.
Station, this is Houston ACR. That concludes the event.
разъем, да? Так.
And it's coming away from the connector.
Так, вот он идет сюда, сюда, сюда.
So it's coming here, then goes down there.
Так, вот он, получается, провод от нашей панели.
So the cable from our panel, we understand, is this one. Yes, it is.
Так, вот он лежит, получается, на середине фиксирующей платы.
So right now it's coming across the middle of the
Подтверждаем, но сейчас откроешь, еще посмотришь маркировку.
restraint plate. Can you confirm that that's the right cable? Yes, but when you open it up and check the labeling, that will be a double sure. Okay.
Так, маркировка разъема СПРЖ 1X1.
It's SPRG X1.
Все принято.
SPRG1 dash X1 is the labeling. Copy Piotr, and that's the right one.
Подтвердили.
Copy, you confirmed.
Так, готов приступить к распаковке разъема.
Ready to demate the connector. Please do.
An excellent view of Oleg Novitsky on the left, Pyotr Dubrov on the right, working at the Zarya module in the replacement of a fluid flow regulator unit. Zarya having been launched more than 22 years ago
In opening.
on a Proton rocket from the Baikonur Cosmodrome in Kazakhstan, the first component, the first element of the International Space Station to be launched in the era of the ISS.
На плате разъем, а разъем панели
Leave the connector on the plate.
сверху в лирку там на панель и клапан закрываешь.
Then close the valve. And demated cable needs to go into a cable clip. Here's the clip.
Тугая.
Is it tight?
Я не две, а в одну закрепил. Потому что...
Хорошо, хорошо, конечно.
I just put the cable in one because I think that should be sufficient to hold it in place. Okie dokie.
Разъем, да? Так.
And it's coming away from the connector.
Так, вот он идет сюда, сюда, сюда.
So it's coming here, then goes down there.
Так, вот он, получается, провод от нашей панели.
So the cable from our panel, we understand, is this one. Yes, it is.
Так, вот он лежит, получается, на середине фиксирующей платы.
So right now it's coming across the middle of the
Подтверждаем, но сейчас откроешь, еще посмотришь маркировку.
restraint plate. Can you confirm that that's the right cable? Yes, but when you open it up and check the labeling, that will be a double sure. Okay.
Так, маркировка разъема СПРЖ 1X1.
It's SPRG X1.
Все принято.
SPRG1 dash X1 is the labeling. Copy Piotr, and that's the right one.
Подтвердили.
Copy, you confirmed.
Так, готов приступить к распаковке разъема.
Ready to demate the connector. Please.
An excellent view of Oleg Novitsky on the left, Pyotr Dubrov on the right, working at the Zarya module in the replacement of a fluid flow regulator unit. The Zarya having been launched more than 22 years ago
In opening.
on a Proton rocket from the Baikonur Cosmodrome in Kazakhstan, the first component, the first element of the International Space Station to be launched in the era of the ISS.
На плате разъем, а разъем панели
Leave the connector on the plate.
сверху в лирку там на панель и клапан закрываешь.
Then close the valve. And demated cable needs to go into a cable clip. Here's the clip. Is it tight?
Я не две, в одну закрепил, потому что...
Хорошо, хорошо, конечно.
I just put the cable in one because I think that should be sufficient to hold it in place. Okie dokie.